In sac218n4, given a coil connected to a resistor, and we're asked to find the direction of the current through the resistor. So it either goes up through the resistor or down through the resistor. We're also told that there's an external magnetic field passing through the coil. We don't know what's causing it, but we do know that whatever is causing it is weakening with time. That is, the number of magnetic field lines directed upward through the coil is decreasing. And we're supposed to explain our reasoning in a step-by-step fashion as to why the current is going upward or downward through the resistor, justifying which way it's going through the resistor in a step-by-step fashion. So first we have to indicate what the original conditions are, so we'll write them down. That is, initially the magnetic field lines, due to an external source, extend upward through the coil. And then we have to establish what the change is, specifically with respect to the coil. We find that the number of magnetic field lines extending upward through the coil is decreasing with time. Okay, that means some of these are disappearing. Let's go ahead and indicate some of these lines disappearing. That one's disappearing with time, due to the fact that the external magnetic field is weakening. Okay, by Lenz's law, to compensate for that, well, first off, by Faraday's law, there's going to be a current induced to flow in the coil. That current, according to Ampere's law, will produce a magnetic field of its own, and by Lenz's law, that magnetic field's got to be in the upward direction in order to maintain the status quo, try to keep the original number of magnetic field lines through the coil in the direction that they were originally extending through the coil the same. So the change was we were losing some. To make up for that, the magnetic field produced by the induced current, I'll call that B pin, magnetic field B produced by the induced current has got to be upward. In this case, because the change was a decrease, it happens to be in the same direction as the original magnetic field. Had it been increasing, to compensate for that, we would have needed a downward one to cancel out newly appearing magnetic field lines. But back to the case at hand, we've got a decreasing number of upward directed magnetic field lines. To compensate for that, try to keep the number of magnetic field lines through the coil upward through the coil, the same as what it was in the first place. We need a magnetic field in the upward direction to be produced by the induced current. Let's see if we can write some of that in words, step-by-step fashion. Step 3, by Faraday's law of induction, changing number of magnetic field lines is decreasing in the decrease of the upward number of directed magnetic field lines is going to cause a current to be induced in the coil. By Ampere's law, the current is going to make a magnetic field of its own, and by Lenz's law, B pin, that magnetic field produced by the induced current, has to be in the upward direction to compensate, make up for the loss of upward directed magnetic field lines. Okay, then, in order to produce an upward directed magnetic field line, according to the right-hand rule, if we stick our thumb in the upward direction, our fingers are going to curl around automatically. In this direction, as the fingers curling around, let's put one of them in there, curling around in a counterclockwise direction as viewed from above. So that would indicate that the current has to be going around the coil in this direction. There's I. Okay, so it'll be counterclockwise as viewed from above, or as indicated, that would be enough. So by the right-hand rule, for something curly, fingers are curly, as is the current. Something straight, the thumb is straight, as is the magnetic field produced by that current. The current in the coil must be clockwise as viewed from above the coil. and that should be counterclockwise, the way I see it. So let's go ahead and switch that. Counterclockwise as viewed from above the coil. And then such a current is going to come out right here and go downward through the resistor. So the bottom line is that the current is downward through the resistor, and it's because of the way the coil is wound. So this would be that step-by-step answer that's called for, and I've explained it a little bit in words as well as we went along. That wraps up SAC 21B.